கௌஸ் நீங்க ரெக்கார்டிங் போட்டுடலாம்.
கொஞ்சம் சார்.
சார் ரிசோர்ஸ் பர்சன் வந்துட்டார், அலோவ் பண்ணவா? ரிசோர்ஸ் பர்சன் அலோவ் பண்றேன்.
மேம் செக் பண்றீங்களா?
ரிசோர்ஸ் பர்சன் வந்துட்டார், அதான் அலோவ் பண்ணி செக் பண்ணிக்கலாம் மேம்.
பண்ணுங்க. சார் நீங்க கொஞ்சம் ஸ்டாப் பண்ணிடுங்க.
ரெக்கார்டிங்கா மேம்?
Good evening, sir.
Yeah, good evening, Dr. Isha. How are you, ma'am?
I'm fine, sir. How about you, sir?
Yeah, I'm fine.
Sir, we'll make you co-host right now, so we could check how your audio and video working out with the presentation that you're posting.
Zoom is not a problem, ma'am. Actually, these days we can see that Zoom is working very correctly. No problems.
Hello, sir. I'm co-host ஆக்கிடுங்க சார்.
ஜினி சார்.
இருங்க நானே பண்றேன். ஒரே நிமிஷம். அப்சல் சார். ஒண்ணுமில்லமா சார், ரிசோர்ஸ் பர்சன் வந்துட்டாரு. அவருக்கு
நான் வீடியோ ஸ்டார்ட் பண்ணிட்டா
அவரை கோஹோஸ்ட் ஆக்கிட்டு வீடியோ ஸ்டார்ட் பண்ணி விட்டுருங்க.
ஓகே.
எல்லாருமே கொஞ்சம் வீடியோ ஆன் பண்ணி விட்டுருங்க. ஃபேக்கல்டிஸ் எல்லாரும் கொஞ்சம் வீடியோ ஆன் பண்ணுங்க.
சார் ரிசோர்ஸ் பர்சன் வந்துட்டாரு.
கோஹோஸ்ட் பண்ணிட்டீங்களா?
இல்ல, எனக்கு அந்த ஆப்ஷன் வரல சார். நீங்க தான் பண்ணணும்னு நினைக்கிறேன்.
சரி.
எல்லாருமே கொஞ்சம் வீடியோ ஆன் பண்ணி விட்டுருங்க. ஃபேக்கல்டிஸ் எல்லாரும் கொஞ்சம் வீடியோ ஆன்
ஒரு பேர் என்ன?
டாக்டர் ஆனந்த் நாயர்.
என்ன பேரு?
ஆனந்த். ஓகே, இருக்கார், உள்ள இருக்கார்.
பாருங்க.
ஆனந்த் நாயர். ஓகே, நான் இது பண்ணிடுறேன்.
ஓகே, இஸ் மேட்.
ஓகே, நான் வீடியோ ப்ளே பண்ணிட்டு can I just go ahead? பேர் என்ன?
டாக்டர் ஆனந்த் நாயர்.
என்ன பேரு?
ஆனந்த். இருக்கார், உள்ள இருக்கார்.
அர்ஷியா மேம்.
Welcome to me.
சொல்லுங்க மேம்.
உஷா மேம் கீழ வராரு.
Corporate in campus experience. We have a lush green environment with well-equipped classrooms and labs. Our environment gives a peaceful mindset and a positive vibe.
சொல்லுங்க மேம்.
மேம் ஸ்கிரீன்ஷாட் மட்டும் எடுத்துக்கோங்க அப்புறமா.
ஓகே மேம். மேம் வெயிட்டிங் ரூம் பார்ட்டிசிபென்ட்ஸ் உள்ள அலோவ் பண்ணலாம்ல? ஆல்மோஸ்ட் டைம்.
பண்ணிட்டு வீடியோ நீங்க ப்ளே பண்ணிடுங்க சார். மேம் பண்ணுங்க.
ஓகே
சார், பிகினிங்ல இருந்தே வாங்க. வால்யூம் இல்ல. அப்துல் சார்.
We have smart classrooms, which gives an enhanced
Welcome to Miyasi Institute of Information Technology. Here we provide a corporate in-campus experience. We have a lush green environment with well-equipped classrooms and labs. Our environment gives a peaceful mindset and a positive vibe.
I was born.
Our director, Dr. Revati Krishnamurthy. She's a dynamic person,
born on
highly
19th
motivated
May,
and concerned
town
about
of
the
Varanasi.
welfare of the
My name
students.
is Manikarnika Tambi,
head of
or
the
nickname
department
Mani.
is Dr. Usha.
Okay, wow.
She's a very
I
enterprising
was
and an
educated at
optimistic
more
person.
different than others. I am married to Raj Kankar, King of Jhansi. Okay, wow. I had a boy, Damodar Rao. After the death of the king, the British annexed Jhansi through the doctrine of Lapsi
We
method.
follow the PRIME pedagogy. PRIME stands for Participatory Learning and Practical Application, and Intelligence,
நான் என்ன சொன்னேனோ அதை மட்டும் எழுது. ஏன் இதை சொல்றதை விட்டுட்டு
and
மத்ததை
guidance,
நோண்டிட்டு இருக்க?
expertise and power skills.
Soft skill classes help us in building the morals, instilling the communication skills, and bringing out the creativity in us.
Our labs are equipped with quality systems, softwares, and high-speed internet. This boosts the quality of a hands-on experience. We have mentoring sessions on a regular basis where we talk to our teachers, share any grievances, and seek support. It develops a healthy bonding between the students and teachers.
Our library is the knowledge resource center of our college. It has an extensive collection of books, journals, magazines, newspapers, references satisfying the academic and research needs of students and
Office staff maintain the day-to-day records of the students and respond promptly to any queries. Mr. Yusuf Mohammed is the convener. He has more than 25 years of experience in the industry and he is a driving force behind the Corporate in Campus initiative. Placement-oriented training is provided regularly. We have aptitude coaching classes, technical training in computer languages. We also have communication training to develop confidence and personality.
CAMU is an ERP software which focuses on paperless work, making learning and office management more efficient. We can have a track of our attendance, reference materials. Our assignments are also scheduled in CAMU, which is very handy as we can access it anywhere.
We have signed MOU with several companies. We get 100% real-time internships, which has helped us to upskill ourselves for placements. Most of our students are working in Tech Mahindra, CTS, Wipro, HCL, and we have received placements in several companies like Ideation, DSRC, Triton, Southnest, Mech Heritage.
Hi, my name is Gaush Sharif and I'm proud to be an alumni of MIIT. I completed my MCA from MIIT in the year 2006 and presently I am working here in Temenos as a senior IT support specialist. When I look back at the years I studied at MIIT, which was accredited by AICTE and were affiliated to University of Madras, I'm thankful to MIIT for providing the students the state-of-the-art infrastructure facility, along with highly qualified and experienced faculty.
Shall we start, ma'am?
Hi. Sir, can we start, sir? Anand, sir?
Yes, ma'am, we can start, please.
Thank you.
Okay. Assalamu alaikum and a very good evening to one and all gathered here. Welcome to the first day of the 5-day online international FDP. A little introduction about Miyasi Institute of Information Technology. It is located in Chennai in Tamil Nadu. It was established in the year 2002. It is accredited from AICTE and it is affiliated to the University of Madras. Miyasi Institute of Information Technology is an independent standalone institute offering MCA program exclusively. It is a co-educational institution and has 120 students in each batch studying MCA. That's about Miyasi Institute of Information Technology in a nutshell. Without further ado, let's begin the program. They say all it takes is a great beginning. To begin great, let us invoke the blessings of the Almighty. I request Mr. Mohammed Gauss, Assistant Professor, Miyasi Institute of Information Technology, to recite the prayer.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين بسم الله الرحمن الرحيم ألم تر كيف فعل ربك بأصحاب الفيل ألم يجعل كيدهم في تضليل وأرسل عليهم طيرا أبابيل ترميهم بحجارة من سجيل فجعلهم كعصف مأكول صدق الله. Thank you, ma'am.
Thank you, sir. I now request Dr. Usha, Head of the Department and Associate Professor, to welcome the gathering and introduce the resource person to us.
Good evening. A very warm welcome to all the dignitaries present today. A special welcome to Dr. Anand, sir, for readily accepting my invitation and honoring us with his presence today. He will be speaking on software-defined networking, foundation concepts, and research direction. I welcome all my colleagues, my director, and other faculty members from various institutions for attending our international FDP today. To introduce the resource person, Dr. Anand Nayyar received his PhD in computer science from Desh Bhagat University in 2017 in the area of wireless sensor networks, swarm intelligence, and network simulation. He is currently working in School of Computer Science, Doi Tan University, Da Nang, Vietnam, as Assistant Professor, Scientist, Vice Chairman of Research, and Director of IoT and Intelligent Systems Lab. Dr. Anand is a certified professional with 100+ professional certificates from Cisco, Microsoft, Amazon, EC Council, Oracle, Google, Bing Cert, EXIN, TAQM, CyberRoam, and many other more. He has published more than 140 research papers in various high-quality journals, which include Web of Science, ISI, SCI, SCI Expanded, SSCI, Impact Factor journals, Scopus, ESCI Index journals. Dr. Anand has presented 70+ papers in international conferences, Index with Springer, IEEE, and ACM Digital Library. He also has 40 plus book chapters to his name in various scopus, Web of Science, Index books with Springer, CRC Press, Wiley, IET, Elsevier with citations reaching up to 6,800 plus. While his H-index stands at 42, his I-index range is at 150 currently. Dr. Anand is a member of more than 60 plus associations as senior and life member, including IEEE and ACM. He has authored, co-authored, edited 40 plus books of computer science. He is associated with more than 500 plus international conferences as part of the program committee, chair, advisory board, or review board member. He has 18 Australian patents, 4 German patents, 1 Japanese patent, and 11 Indian design computability patents, 3 Indian copyrights, and 2 Canadian copyrights to his credit in the area of wireless communications, artificial intelligence, cloud computing, IoT, and image processing. He is recipient of 38 plus awards for teaching and research, which include Young Scientist, Best Scientist, Young Researcher Award, Outstanding Researcher Award, Excellence in Teaching, and many more. He is listed in top 2% scientists as per Stanford University 2020-2021. He is acting as an associate editor of Wireless Networks, Springer, Computer Communications Elsevier, International Journal of Sensor Networks, IJSNet, and Frontiers in Computer Science, Field Journal Computer Science, Human-Centric Computing, and Information Sciences, IET Quantum. Dr. Anand is acting as editor-in-chief of IGI Global, USA Journal titled International Journal of Smart Vehicles and Smart Transportation. He has reviewed more than 2,000 plus articles for diverse Web of Science and Scopus Index journals. He is currently researching in the area of wireless sensor networks, Internet of Things, swarm intelligence, cloud computing, artificial intelligence, drones, blockchain, cyber security, network simulation, big data, and wireless communications. We are indeed honored to have you among with us, sir. And without further ado, please chair the session.
Sure.
A special mention to all the other participants to kindly mute yourselves while the session is on. Thank you.
Thank you, Shama, for that warm welcome and a detailed introduction. Just a request to all the participants, kindly mute your audios for the better experience and to avoid any disturbance. Over to you, sir.
Okay. Can you see my screen, everybody? Thank you. Can you please confirm me with your message?
Yes, sir. Yes,
Yes,
sir.
yes.
Good evening, ladies and gentlemen. I'm Dr. Anand Nayyar, and I'm working as professor, scientist, vice chairman, research, and director for IoT and Intelligent Systems Lab. Before I should start, I would like to inform all of you that I was assistant professor 2 days back, and just today morning, I was being promoted to my department as the vice director and even the professor of computer science in the war industry. Today, I got my promotion. So before I start my session, I would like all of you to please mute yourself. And man, please do something of the ringing of bells and admitting the people, please. Thank you. So ladies and gentlemen, today we talk of technologies. Today, when we talk of technologies like Internet of Everything, Industry 4.0, cyber physical systems, wireless communications, and of course, when we talk of edge computing, drones, we are always coming among the one common term, which is really, really common, that is software-defined networks. And today in this FDP program, I will be giving some lecture on software-defined networking, what are the insights and what are the research directions. And technically speaking, all of you, that today even we have launched some projects of software-defined networking. One is in front of you, that with Wiley, and that is software-defined networks, architectures, and applications. And very soon, by the next month mid, we are going to launch this book also with CRC Press. And even we are signing 2 more contracts with the Elsevier. And even I'm getting my 2 more transaction journals with IEEE on this aspect with regard to software-defined networking. So ladies and gentlemen, I would like to give you some lectures with regard to software-defined networking. So it is very important for you to understand this terminology, because when we talk of today's technologies, as I've already told you, software-defined networking plays a very crucial aspect, very crucial. And today, when I go to some of the labs in USA, in Korea,
Participants, kindly mute yourselves.
Tabana H, can you please mute? Thank you.
Okay. Madam, I appreciate that this should not happen again, because if anybody is disturbing or unmuting itself, you can remove the person from the meeting. Let's be professional here. Thank you so much. Because disturbing the keynote speaker is really you can say, indiscipline in the meeting, please. So everybody, I would like to tell you that when we go to some of the labs in USA, in Korea and Taiwan, they are working very aggressively in the area for software-defined networking. And of course, if you talk of some of the technologies that are really dependent on SDN, today we are working on two more aspects, that is Industry 4.0, and we are even transferring our aspects to edge computing, which is based on drones. So if you talk of the futuristic technology, SDN is going to lay the foundation as a middleware and even as a foundation of stepping stone towards the advancements of the new technologies that can come and even hit the market in next 4 years. So ladies and gentlemen, in this FTP, when Madam has contacted me, so she has also asked me that, sir, can you give us some futuristic lecture? So I would have told her one thing, that let us take some futuristic lecture with regard to some of the things that can be useful for the futuristic technologies. So SDN was one of my favorite aspects that needs to be discussed out. So ladies and gentlemen, I would be discussing that how we are transforming our traditional network to software-defined networking. And of course, when we talk of traditional network, we are talking of our routers, we are talking of our switches, we are talking of data plane and control plane. But now when we talk of software-defined networking, we are actually having programmable technologies. When we are talking of programmable switches, when we are talking of control machines that are taking control of each and every network of yours. Now, considering, suppose if you want to have a drones or a cluster of drones in the network, so rather than to fly the drones, let us program a software for the drones, that how these drones can monitor, track the area, and of course do for some object tracking, and even they can report what are the new movements in a particular in the particular area. So all this can be done with software-defined networking. But applications can be tremendous, but I will not be talking about many applications today, because if you want me to talk on applications, I can even take the whole lecture for more than next 3 hours for only applications, because we are even working in our lab. And one more thing which I would like to include in this presentation, which you will see in this later part of my presentation, is that you will see my lab, which is also a state-of-the-art lab for SDN and even for drones that we are doing. And we are doing some projects with, I will not tell the name of the companies, but I'm doing some projects with the top corporate. And even we are integrating software-defined networking in autonomous vehicles also. That is the futuristic approach that we are taking right now. So let me share the full screen with all of you. So the topic of SDN is really an approachable topic and needs to be discussed today. And if anybody is interested to perform the research, I would like to tell you that this is the time that you can perform your research, because lots of publications and lots of publication houses, they are aggressively publishing the papers with regard to SDN. And even we are writing 2-3 papers with the biggest review of software-defined networking and how SDN is playing a crucial role in the future of smart homes and drones, which will be published soon by the end of next month. So if you see my Google Scholar, you can see some of the publications are already there in the area for software-defined networking. So this is some of my introduction photos, everybody. You can see that this is the picture one, which is concerning of the LoRaWAN, which is also having some SDN based properties. And even we are working on drones, and even we are working on the robotics that can take SDN as a base for technology. So my introduction is already done, but I would like to tell you something about myself, that I have published more than 170 SES today, and my citations are crossing 7,000 with H index of 43 and I index of 152. And even I'm having 8 inventions, 60 plus patents, and 13 copyrights. And even we are applying for 10 more US patents this year, which are all concerning with regard to artificial intelligence, SDN, and drones. So the question stands in all of you, everybody, that what is meant by SDN? So we should know that this presentation and this FTP, I will be taking care of you, that you don't know anything about SDN. You should start as a baby step, but this is very important for you to understand, because most of the people make it confused. They only say that, okay, it's an advanced networking, we can program some of the controllers, but it is not enough. SDN is much ahead of that. So you need to understand that there are 2 types of things that will be taken care of me in this lecture. That will be control plane, and the second is the data plane. Okay, so make it sure that these are the problems with regard to current networks. And ladies and gentlemen, I would like to tell you that even though you put any types of firewalls, even I'm a computer hacker, so even you put many firewalls or you put any type of security on the internet and the data communication will always remain unsecure. Every day we have problems with regard to the security, encryptions and everything. But when we talk of software defined networking, the primary foundation is that everything from the user to the server and from the server to the data centers, it always remain encrypted. It's like a tight military security. That is the reason that SDN was actually laid the foundation, and we actually require SDN to the tons of the hybrid applications of industry 4.0 when robotics and of course the advanced human machine interaction can take place. So let us start with the question that what exactly is SDN? And I will talk from the very base now. So everybody, you can see that it is an agile networking architecture. So as we know, as a teacher of software engineering, what is agile? Agile means that it is purely flexible and scalable as to design and as to upgrade. But the main thing is that today's applications of industries are changing. Even I'm running my company in Hong Kong, and when we do some operational capabilities for lots of the companies, like today, when we talk of fintech organizations, when we talk of organizations that are working with RPAs and blockchains, the customer requirements are really dynamic. When we talk of the network applications of autonomous vehicles, when we talk of network intelligence, machine intelligence, data learning in terms of healthcare informatics, the scenarios for networking and the hybridization of the communication, the scenario totally changes. And for that, everybody, we need a decoupled based network environment, which is totally agile. And of course, it can keep up the pace when the requirements are totally changing. So today's network, when we talk of traditional networking, once it is done, you can just upgrade them. But when we talk of software defined networking, we are actually adding up the agile based modality in the networks. So an opportunistic based network environment where data planes and control planes are decoupled, and we are having a complete abstraction from the applications. So ladies and gentlemen, when you put up the APIs and the SDKs as the core components, you make up the SDNs. So the main thing is that today, when we talk of Web 3.0, when we talk of JSON, when we talk of web APIs, where everything needs to be tightly coupled. Even I'm a programmer of blockchain, and when we do lots of programming with regard to Solidity, and we try to make up cryptocurrency, when we try to add up the Bitcoin mining, so these type of technologies needs advanced communication, advanced integration of APIs. So ladies and gentlemen, let me tell you that this type of abstraction, this type of real power, where the generalizations, when the specific codes to the devices needs to be highly scalable and highly generalized, then SDN comes into being. So the bottom line of the story is nowadays, when we talk of the advanced applications where networking needs to be flexible, where data and control needs to be highly scalable as per the customer requirements, and to make up the explanations with regard to data center based communication, SDN come in the place. So let me tell you today, if you talk of the latest keynotes by NVIDIA, they're also working on tons of the graphic based processing units. Now we have the advanced tensors. They are even adding up more and more data centers with regard to AI over the cloud. So that type of information things requires software defined networking. So software defined networking, you can see that it has changed the networking like we have ever seen before. At one time, the data plane and the control plane were working together. But now with SDN, the data plane and the control plane are working differently. That is the main advantage. So if anybody asks you what is the core difference in traditional networking, both of these things work together. But when we talk of SDN, both of these things are actually separated. And APIs and SDKs have become a strong component. And now with the agility, it can support the next generation virtualization. So when we talk of SDN, it is basically providing you the network brain, which is programmable. And of course, with the high-end infrastructure, when we talk of cyber physical systems, robotics, Internet of Everything, even the customized communication systems like 6G or 5G, this type of SDN communication network needs to be updated. So when we talk of SDN, everybody, it is becoming very fast. It is becoming really scalable. So, but the main components are threes, that is known as controllers. These are the brains of the computer, of the network that you can say. And of course, it is having some basic differences and it is having some basic underlying systems with regard to switches and the routers, which can even go for the flow of the data from one place to another place. Now, when we talk of southbound API, we have OpenFlow. I will not talk about OpenFlow much, but I will be just giving you some comprehensive overview that what is OpenFlow. So basically, it's a common protocol through which you can say that it is making up a bigger landscape, that how you can communicate and how you can make it more agile as per the requirements. So when we talk of TCP/IP protocols, these are the protocols of traditional networking. But when we talk of OpenFlow, it is a modern protocols for SDN. So remember that if anybody wants you to program something or you want to reprogram some of the network, you need to reprogram with OpenFlow. And of course, with northbounds, you can see that we use northbound APIs to have better business logic, and you can have your network administrators, you can deploy your cryptocurrency, you can deploy your drones aspects, and even you can perform some of the aspects with regard to cyber physical systems. Now, today, everybody, even I'm working as a systems integrator, when we go to the industry and we take the requirements of the robotics. Now, when the robotics have come to the official on-site to the customers, we don't program with you can say traditional programming. We have some explicit programming over there, and that can be only done with the power of software-defined networking. So you have even seen my robot that is also there. So we don't have to take the robot back to the lab. We just make it connected to the internet with the data center, and we upgrade the code, and we just make the robot to do the flexible task in the real time. Okay, so let me tell you, ladies and gentlemen, that when we talk of the high-end applications of the future, where you don't have to scratch your code or update the code from the base, you just need to add up more and more APIs or more flexibility to the operations. The OpenFlow or the SDM or the SDKs will be the most important thing for SDN communication network. So you can see that this is the SDN network controller system, and these are the three major aspects of SDN, which is programmability, the separation of data plane, as well as the control plane, and of course the management of the empirical network state, which is able to go for decentralization, or you can say the higher degree of centralization. So you can see from the base, you can see that we have the third party network, and we are having our own legacy networks, and we have multiple clouds. Now, there was a time when people were only relying on private clouds or public clouds. But nowadays, when we talk of industries, we are actually working to community clouds, which means that one of the biggest companies can take the higher end infrastructure from Amazon, and a company like me can even hire that cloud as a temporary thing in order to update and to merge up my applications, go to the clients, go for deployments, and then we can go for more MOUs. And now you can see that it is an orchestration platform in which we have the service loop, we have the orchestrator, we have the dynamic inventory, and of course, everything can be taken care with BSS and OSS. Now, this is what you have to understand, everybody, that actually SDN is not from the scratch. We can merge up SDN to our traditional networks. We can add more orchestration. We can add more flexibility like an agile environment, and we can make it more flexible and scalable as per our customer requirements. Now, software-defined networking, you can see that it is basically having, but there are some applications that still rely on network that is requiring some packet headers and other things. But when we take off SDN, it works into the two modes. One is proactive and second is reactive. Now, as a researcher, everybody, I will not say proactive is more heavy or reactive is more heavy. It depends on your applications. Now, the most important thing is if you are talking of proactive approach, you are basically into the networks, routings, and of course, you make up the infrastructure. And even let me tell you, ladies and gentlemen, that tomorrow, if you want to plan a high-end cloud, but no doubt, high-end cloud, nobody plans. Who will say you that you are a fool to make your own cloud infrastructure where Amazon, Azure, and Google and IBM is already there. But if suppose you want to plan your in-house cloud infrastructure, then go for proactive approach. But when we talk of supporting of dynamic applications like RPAs, the chatbots, the autonomous vehicles, then we are taking up a reactive approach. This is where we come up and we can take a reactive approach when we go for programming for smart homes and of course for drones also like that. Now, ladies and gentlemen, I would like to give you one example. Like, I don't know how many of you have come to Vietnam, but if anybody plans to go to Vietnam, you are most welcome to visit my lab. Now, I'm associated with the top company, like we have Infosys in India. I'm associated with top 2 companies of Vietnam. One is the VinFast, which is also making the cars, Vin Homes, and even they have their Vin University, the Vin Marts, Vin Hotels, everything. They are the biggest companies in Vietnam. And second is FPT Software. Now, let me tell you, ladies and gentlemen, VinFast company has come to me and they asked me that, sir, can we make a flexible smart home? Like suppose today, if we program a one room and tomorrow we program the entire building, and after that we make an entire smart city ecosystem, can we do that? And I have told them one answer that yes, we can do that. But the only thing is that we need to make up a hybrid controllers and we need to depend morely on the software defined networking. So the traditional smart homes that you can say from the stage one, when we only have sensors and one apps and some technological gadgets, that is one time. But now the things are getting changed up. Now the main thing is that you need to program, you need to get reprogrammability, you add up middlewares, and of course you can make up a flexible smart homes of the future. What if I tell you that today we are even working on a flexible smart home, that today if suppose you have made a Philips Hue environment in your home and tomorrow you want to upgrade it to Alexa, so you don't have to change the entire Philips Hue, you just add Alexa, make some programming so that Alexa and Philips Hue can combine together and they can work in a comprehensive manner. Now that's the reason that Open SDN is actually making up all the things in the cluster and working them together in a hybrid mode. Now this is the power of SDN. I hope now you are able to understand that SDN is not only a friend, but it actually provides a middleware. It provides a platform so that everything works in an agile capacity. The main thing is agile capacity. And even today, if you talk of software companies in Vietnam, which are mostly programming in blockchains and even on RPAs, and even when we talk of some .NET and other hybrid mobile applications, we only follow agile methodology, not any other methodology today. So SDN3 deployment models, you can see that we have the model, which is Open SDK, which is OpenFlow, which is available from Open Network Foundation. You can download and you can start the work. And for the SDN via RESTful API, it is available from Cisco. And we have the SDN via overlay, which is done with VMware. And you can go and add more information from their websites. Every day they are updating their RFCs, they are upgrading their information over the internet. But let me tell you, ladies and gentlemen, setting up a SDN lab is not very complex. You just need 5 to 6 computers. And after that, you need some open source softwares and you can start the working over there. But the main thing is what kind of hybrid application you need to base on that. Because don't mind, because SDN can only work once you have something application over the mind. So we have the application that is based on drones and smart homes. That's all. So SDN orchestration, you can see that the centralized control panel can be programmed by using different central entity. One is the SDN orchestration, in which you can perform everything in real time. And even there are a number of ports available, the resources, the ports, the memory, everything you can program. And once we talk of control plane, it is basically programming how we will able to do the programming of network shifting and how we can perform some data transmission from one node to another nodes. And let me tell you everybody that the SDN performs so better that you can add clusters of nodes without any problem in this infrastructure. Everything is totally dynamic. And this is the network operating system for the network, which I will be clearing you. And you can see everybody that we have protocols which are based with network operating system. This is the global network view. And over there, we install our programs. So everything is programmable network operating system. So if you want to even practice over there, you can even download the Boson network simulator from Cisco and you can do your work. Even you can download one simulator called OpenNet, which is even open access. Even there are lots of kits that are available for SDN with regard to NS3 simulator. Everything is flexible. No need to buy any simulator. Everything can be done with free and open source softwares. And let me tell you, its community is really big, really big. If you put up any question over there, you get a reply in less than 20 minutes. It's so much active. So this is the network plane, and you can see that data plane is processing all the delivery of the packets from control node from the data plane. And of course, from control plane, we can orchestrate the routing traffic, the service delivery, everything. And the management plane is basically moving towards automation, where we perform all types of traffic engineering and DevOps. And one more thing, ladies and gentlemen, that today, if any of the student is listening to me, the most important thing that you need to understand the career, which is really super important for international community, is DevOps. So if you are really looking for a fantastic career internationally, DevOps is the answer. And when you go for DevOps based operations in any organization, you will find that you will work in an environment of SDN, because today's DevOps are only based on SDNs. So this is the network controller, and you can see that we have the broadcast traffic, we have the encoders, we have the schedulers, and that is all hybrid connected towards the network controllers. And after that, we can provide some abstraction layer. We have the open standards, we have the orchestration, and this is the API that you can program over there. So everything is working with the controller, with the network framework, with the application controller, and the broadcast network controller. And let me tell you, everybody, that every layer and every component has an abstraction so that complexity can be reduced to the drastic level. Now, if I tell you that, okay, sir, let us program some IPsec or some VPN tunnel or gateways or other things, the project will be becoming really complex when to accommodate long number of users. But over here, when the project is completed, you can even orchestrate, you can even update it without any problems with regard to hyper tuning of all the parameters. And trust me, I started my career as a Cisco certified network professional and associate. And today with SDN and with DevOps, I'm able to perform high-end projects in matter of hours. Before that, it was days to even months, but now it is really flexible and agile. And you can see that this is one of the examples with the SDN platform deployment. And today, if you talk of the biggest platform, which is accommodating SDN, it is OpenStack. OpenStack is one of the benchmarks that you can learn with orchestration. No doubt today we have Puppet, we have Ansible, everything is well connected to DevOps and even to SDNs. So you can see that we have the NFV virtual, which is actually connected with a physical layer, and we have the southbound plugins with OpenFlow. OpenFlow is the main protocol, and we are connecting it with the RESTful API. And everything that can be performed is the help of XML and JavaScript, or even you can use JSON, or even you can use blockchain as Solidity. So these are some of the platform plugins. You can note it down. And if you ask me, one of the most important example that you can do, it is OpenFlow 1.0 and 1.3. Even you can use the Red Hat and RHAL, even Ubuntu, and even you can use some open source service interface, which is also with Apache Karaf. So let me tell you, everything is open access. Everything is good. You just need to have a system of 16 GB RAM, and with an Intel Xeon or with Intel Core i9 or AMD Ryzen 9, you can make up a good system that can perform OpenFlow or even like SDN based communication network based research. So this you can see, everybody, I will not explain to all of you. I think everybody knows about from the book that even if you have read Tannenbaum or Todd Lamley of CCNA, you can see that this was the traditional broadcasting. And it was, again, I would like to tell you that it was not very rich into optimization, rich into communications, and rich into speed. But when we talk of modern communication networks starting from 5G or 6G, when we talk of WiMAX, and when we talk of the hyper connectivity of the mega cities to make them as a sustainable network, then this type of advanced SDN, they comes into being. Now you can see that today we have the multimedia like this, when everything is connected. And today, if you talk of the top companies like YouTube, Netflix, and even Hotstar, they are all connecting and even managing their IP communication network with SDKs. So this is the next generation broadcasting high level infrastructure, everybody, where the backbone will be based on WiMAX or 5G. Okay, we will not talk of 4G today. We will talk of 5G. And after that, we have the BMX communication network. We have the data collection analytics. And of course, with the power of artificial intelligence, we can able to have cost optimized solutions, highly scalable, high bandwidth, and of course, the dynamic architecture that can even go to layer 3 based networks. So this is the next generation 5G, everybody. This is very important for you to see, and please see this figure properly. Now see this, how this 5G will be able to take place. And SDN, you can say it provides a seamless integration. Ladies and gentlemen, today you will agree with me that if you go on a big stadium and you start taking photos, anybody is working with Instagram, anybody is uploading the videos on YouTube, you are surfing the internet, the requirements at a particular level becomes tremendous. And for that type of requirements, the 5G communication network needs to be more solid, hybrid, and scalable. And let me tell you, the future will be not only cognitive radio ad hoc networks, but the future will be based on open SDN. So this is where you need to work and find out that how you can make up more hybrid applications. You can write a paper that let us make how we can have some high-end communication network of industry for 5.0 with robotics, cobotics, human beings, with 5G as a base, with tons of these services, and everything is programmable with SDN. This is how you can make up your research papers. This is how you can propose your own infrastructures, architectures, frameworks. Please mute yourself. Thank you. So SDN networking, you can see everybody that it is comprising of the switch operating system, the switch hardware, and everything is programmed with network operating system. Everything can be programmed, everything. And after that, you can have some virtual stack of all the applications where we have the southbound API, decouple the switch hardware from the control function, and we have the switch operating system that can even program all the hardwares and network communications. So exactly SDN means that every hardware that is connected in the ecosystem, it can be programmed, it can be optimized, and you can program as per the user requirements. You can even tune up. Today, if you have 100 users based cluster for cloud computing, you can program it for today. But when tomorrow the customer requirements change it to 1,000 clusters or 20,000 clusters of computers, you can even reprogram them. No need to go back and no need to, you can say, hyper tune the parameters and other things. Everything is programmed. So this is the southbound interface environment when we have the network configuration in terms of BGP. But today, when we talk of L3 and MPLS, these are super important. When we talk of actions, we have the L3 forwarding and we have encapsulations. Flexible matching can be done with VLANs, flexible actions with encapsulations. And of course, we have the modern controllers or that are which are having their modular and flexible approach with regard to C++ and Python. And today, ladies and gentlemen, if anybody wants to go for more advanced SDN, that is only programmed with Python. And needless to say, today, when we talk of your AI, deep learning, it is all based on Python. Even data science today is only based on Python. So these are some of the implications of SDN where you can have the present networking. You can see that it is distributed. Each switch has a brain. We have to configure all types of protocols. We have to configure the speed. We have to configure the security, everything. Okay, that is time consuming. That is totally, I'm saying you, very, very reluctant process. Even I will not do. And today when any person calls me that, sir, we want to add up some infrastructure, we just take the requirements that what kind of server you need. You need a Windows server, you need a web server or email server. We go to Amazon, we put some instances and we configure the servers there and we put them with their username and IP address, with the username and password, and they can start their work. But when we talk of SDN enable environment, we can see that when we start with switch, when we start with routers, and when we go for southbound APIs with SDKs, everything is controlled with operating system, and that operating system can be programmed and applications tuning can be done like anything. So this is the area there where you can work, that if you are working in an institution where you are going for a hyperscale ERP system, which will be not available inside the campus, but outside the campus. When you are talking of high-end media streaming services, when you are talking of high-end broadcasting services, when you are talking of hospitalization-based cluster ecosystem, the connectivity, Internet of Medical Things, AI in healthcare, when you talk of 5G, this type of environment plays a crucial role when we add the new definitions, when optimality can come, and we fine-grained control over each and every devices that you can see on the internet. So this is the data pane, everybody, and you can see that basically it is known as a forwarding pane, and it is basically known as the router. Now, what is a router? It converts the packets from, you can say, the data link layer, and it transmits the packets to the upper layers of the network. So it is having its own routing table, the forwarding table, the packet forwarding table, routing base, forward information. So if you talk of the real-time networking or traditional networking, we have the routers, but when we talk of the SDN, we have the data panes. So everything can be programmed and they can be having their own routing information table, the same by the book procedure that we see in our networking books when we go for computer networks based study. And this is the control plane. This is basically known as the brain of the network. It is updating all the routers. It is actually performing all types of traffic engineering, signaling, and even it is also performing the topology control of the network. So data. Excuse me, ma'am. Hello.
We'll remove, sir. Don't worry. Carry on, please.
Madam, you remove the person, please.
Yes, sure, sir.
No, please. This is utter nonsense that the person is disturbing us with the songs. So you can see that it's the control plane, which is actually performing all types of control activities, the signaling, the updating the routing table, the brain of the network, everything is performed with control. So let me tell you, ladies and gentlemen, the basic thing is that you perform the networking. The routers are also programmed, that is known as the data plane and control plane. These are the central servers that can also be programmed, and they control all the data planes and the other communicating devices in the entire network. So this is the main diagram that you can see. It's a very rare diagram that I have done for all of you. That is the management of control and data planes. When you can see that there is an adjacent router with OSPF, you can say the routing tables, and we have the management policy where we have our own configurations, the forwarding table, and we have the adjacent router where we can put the control plane and the data plane. So you don't have to change the routers. You just add up your networking based configurations and you make them more flexible for the clients. That's the only answer. I'm not changing traditional networking. I'm just adding the flexibility and some more agile operations to traditional networks so that they can perform better. They become optimized. I can tune them and I can tweak them in order to perform for the latest requirements, which is the hyperparameter requirements of the current users. That is totally different as compared to the network communications 10 years back. So SDN is a technology that can take the traditional networking with some few adjustments with programming of Python and JSON to the futuristic thing. We don't have to change the baseline infrastructure. Okay. So you can see this is the architecture, and the most important, you can see from the bottom, we have the same network nodes, we have the switches, we have the virtual switches, we have the routers, we have the access points, and we add up some more protocols with southbound APIs. So most important protocol, I've already told you, it is open flow. And after that, we have the control plane, which is known as the controller, the brain of the networking, which has its own controller with eastbound and westbound. And after that, we have the northbound API, where we can use open API or RESTful API, depending on you, whether you can go for open access or whether you want to go for Cisco. And today, IBM and even Microsoft and even Oracle, they are working a lot to make up their own protocols. But the main thing is that you have to pay somewhat subscription fees to them, which is almost negligible. But if you talk of the stable protocol, that is even open API. So if anybody wants to research in SDN, I always tell you, I always recommend you, even as a researcher and a scientist in SDN from last 3 years, that go and open and go for only open access protocols. And you can see the applications could be tremendous. When you talk of today's applications like chatbots, RPAs, blockchain, the integration of hyper tuning parameters, integration of cloud computing, integration of AI in data centers, edge computing, because today we don't have to change everything. We just have to add few more tweaks in the existing infrastructure to make it modern in approach and to add and accommodate more and more users and requirements like never before. So you can see on the right hand side, infrastructure layer, it's the same layer that has the gateways, routers, Ethernet, and it is acting as the data plane. But we have the control layer, which is known as control plane, that is the central brain, and southbound interface, which has the APIs. So remember everybody, like we have the TCP/IP model, it has the 3 important layers: the infrastructure layer, the controller layer, and the southbound interface. Same routers, switches, and internet, controllers, and of course with protocols. So this is one of the example that you can see, and the traditional networks that consist of routers, gateways, everything, they can be added with RESTful API. They can be programmed with network operating system. And of course, we can add them to the more advanced communication systems like anything. And the RESTful API is only added at the SDN controller. So you have the traditional networking, don't touch it, add a SDN controller, program with some network operating system, and add the few more applications. So this is the answer, everybody, that when you talk of the companies like Airtel or Vodafone, when they want to roll out 6G services of the future, so they don't have to change the antennas, they don't have to buy the new routers, they just have to add the more SDN controllers, and with the RESTful API, they can migrate the networks to operate for 6G or 5G of the future. Now, this is the SDN App C controller. This is where we are doing our research. And this is one of the controller that we are doing our research with a part of drones. Now you can see that this is the APC controller, which is provided and handled with the BMX components. We are not concerned with any company, but we are making our own infrastructure customized for our application. Now my work is that let me explain some of my works to you. My work is that if we are now these days we are doing that also. Like suppose I'm going for a one company is coming to me that, sir. So one company is coming to me that, sir, we want the drone monitoring 24/7. And you will all agree with me that drones cannot fly for 24/7. Okay, so what we are doing is that we are making some open SDK controllers that will have the battery operations. Like suppose a fighter plane, it has to do continuous monitoring, which means that it is a refueling in the air. Similarly, the SDN controllers based battery-based drones will fly and the drone will communicate with them and the batteries will be replaced in the air. So the drone can be operational 24/7. So SDN application controller, you can see that it is having the same operations time to live. So this is one of the life cycle state machine, which you can convert in terms of vendors, the cloud deployments, OpenStack. But we are not using OpenStack today. We are collaborating with Microsoft with Azure platform because it will become more easy and tuning up for more applications for RPAs and chatbots. So I've already explained all of you to this. And now this is one of the client side example where you can see that how we are adding up the events. And if suppose a client gives you the requirement that today we want to add extra layer of security to our company, we want to add some extra layer of automation, business process monitoring over there, what you will do, you can do with this type of SLI. Okay. And okay. So I can give you one more example. Yes, this is the example which I would like to tune. And after that, I would like to take some of your questions and I would like to wind up my presentation in next 10 minutes. So you can see everybody that this is the API, which you can see from the bottom layer, which is having encoder and it is routing the traffic. And we have the APIs which are connected to Exciter 3.0 and which is also providing a type of API with regard to interfaces in terms of application layer. And we have the same traditional integration layer. We are adding up the big data. We are adding up the interface layer and we add more types of applications. Now imagine everybody, what if I tell you that if your traditional network is there with more than 25 routers and one firewall and even one gateway, you put this on one side and we add another infrastructure, it will migrate and it will add more components and we can even add artificial intelligence to that. Now imagine what we can do with traditional companies and they can even become as a SDN controller for the future. What we can do now, the applications could be tremendous. Even some companies in Vietnam, they have even come to me that, sir, we have the 3G communication network. Sir, we are a cable TV network. We want to provide some extra layer of services. We want to provide some leased line services. What we should do, we can't change our main infrastructure. We can't add more infrastructure to our traditional things. So the SDN is the answer for that. So if anybody comes to you that, sir, we don't want to touch the old infrastructure, but we want to add more infrastructure for the future. So Agile and the SDN is the knocking stage for all of you. It's a monster. You can see the applications are tremendous. So this is, you can see SDN by OpenFlow, where OpenFlow controller is used to act as a data plane. And even it also includes the control plane. Now that's the answer, everybody, that why do you need to focus on OpenFlow? Because OpenFlow can give you the platform to test, to rectify, to update, and even it can simulate. Even it can simulate the toughest of the toughest 5G and autonomous vehicles infrastructure. But if you download Cisco, it is even more advanced. Okay, and all the programming, no need to worry. It's all the programming codes, you can find it on Stack Overflow and everything is based on Python. And you can see right now that it is the Ethernet switch and we are adding up some packet forwarding or OpenSDN controller. We are adding the Python programming and this will be controlled using Open Network Operating System. So even your OpenFlow protocol can even be installed on traditional switches. Yes, it is now possible with version 1.3. And after that, you add the control planes, you add more applications, and let us have the better infrastructure with your traditional infrastructures. Okay, so you can see, everybody, that what are the drawbacks of the current broadcast networking complexities? Scalability, it is not scalable. We have the vendor dependency, and of course, they are also having little features. But now for the new broadcast strategy, we can see that we can change the traffic pattern. We can change the traffic patterns. And of course, we can broadcast the network infrastructure platform. We have the better application platform. We can add cloud computing and AI data center support. And of course, the applications like RPA, AI, the cloud data centers can even be added to existing SDN controllers. And this is one of the things that I would like to tell you. Yeah. Now, this is the area that you can see everybody, and this is the application interface, which you can see that right now, most of the companies in Da Nang City, they are coming to my lab that, sir, we want to roll out some 5G services. Sir, in the future, we are also planning to roll out business process automation, what we should do. So what we do, we just add some open flow based programming. We connect them to the network operating system. We hyperscale some of the parameters. We add more routers and gateways and control planes, and we can have end-to-end service orchestration. Now, today, ladies and gentlemen, at one time, not everything was into our control. We just have to plug and play the devices. But now those plug and play devices can even come under the API control. So remember, the things are becoming changing. We will have more control over the security. So this is one of the platforms that you can see, everybody, that how we can see that at one time we have the data pipeline with regard to Industry 4.0. We have smart devices, the IoT based radical ecosystem, and we have the mobility networks. So everything is added to the open SDN controllers, and we are adding up these type of layers at the backend, in which there is a service convergence layer, the broadcast physical layer, the NFL layer, the resource layer, the service layer, and of course the tenant layer. So everything is coming under the hyper scalable communication network. That's the reason, everybody, that we are totally interested for SDN implementations in the near future. And this is where you can see that how the big data gets connected to SDN. So right now we are only talking of two things. That is, you can note it down. One is Hadoop and second is Apache Kafka. Right now we are also adding up our research to how we can add Splunk into this type of infrastructure, and we can add up better, highly scalable storage systems. So remember, we don't have to depend on the traditional data centers. We can even add up big data storage like a plug and play device, like a USB system to the existing traditional networking. So open SDN is so flexible, everybody. Whatever you think of in today's infrastructure, it can be added up with Open SDK like in just 10 minutes, and it is working like a magic. No problems at all, because why? It is open, it is highly tuned, it provides a resource, it adds the control system, it adds AI, it is openly available for everything. So this is Kafka, everybody. You can see that I've already told you that today, if you talk of big data, we are only working on Hadoop, and second is Kafka. So what is Kafka? Basically, it's a distributed event streaming service that can handle trillions of events in a day, because today's systems are actually big data systems. Customer, consumers, producers, everybody is connected on a centralized system. Now imagine blockchain. So to handle this type of transactions, we need a distributed committed log. So Kafka is one of the platform for that. So it is even open access. So this is the brief architecture that you can see. It uses a zookeeper that can even clusterize your all types of brokers and the system's data. And of course, everything can be performed with the help of Kafka. And today, Google, Microsoft, Search, the Bing, and even Facebook, they're using Kafka as one of their platforms for performing Open SDN. Now, I would like to give you one or two more things, which after that I would like to tell you. Yeah. So the conclusion is that we have done what is SDN, what is SDN via API, which I've already told you that if you really want to do the research, you can do with Open Flow or even with Cisco RESTful API. That depends on you and how we are enabling the SDNs. But of course, in the future, what I'm working right now, if you can see my publications on Google Scholar, we are working on drones, and we are actually working on one or two things which we want to start our research like soon as possible, is digital twins and metaverse. And we want to explore the opportunities that how SDNs can be able to explore into these fields. When we talk of healthcare, when we talk of Industry 4.0 based automations of cyber physical systems. So with this, everybody, this is a complete thank you from my side. Thank you for inviting me. And if anybody wants to have any question now, if you want to ask me any research question or anything with regard to OpenSDN or any of my research experience, you are most welcome. And I will take your questions like anything. So thank you so much for inviting me.
Thank you, sir. It was such an in-depth presentation. It was really informative. Participants, you can unmute and ask your questions, or you can post it in the chat box as well.
Sir, good evening. This is Leela Rani. Can you hear me, sir?
Yeah, of course, madam. I'm able to hear you. So
Sir,
please go ahead with the question, please.
Sir, can you tell me what is DevOps? I heard that term today only. Sorry, I haven't heard it already.
Okay, so ma'am, actually, do you have any experience with automations and everything?
Sorry, sir. No, sir.
Okay, so suppose if I tell you now, I will give you a very brief explanation.
Others kindly mute, please.
Madam, I'm getting
I'm
disturbed.
trying to. No, I'm trying to.
I'm getting disturbed, madam. Please, first of all, mute the people and then I will work on that.
Can proceed, sir.
Okay, ma'am. So please tell me your name again and then I will start with the explanation. And it
Sir,
is really interesting. It is really interesting answer. And I would also like to request Madam Usha to have one more lecture of mine in the future with regard to DevOps, because why? I'm a certified DevOps master. And even I have done more than 20 projects in Vietnam, Thailand, and Taiwan, where companies of software development and IT operations are combined together with the help of this. Now, let me give you the answer first of all. Madam, DevOps consists of two words. One is called developer and second is called operations. Now, let me tell you, in IT companies, there are two types of teams. One that develops and second which performs the operations. Now, suppose you are a software developer and I am the IT operations like a network administrator or software tester. So if you do the development, then you transfer me there, then there is a problem or other things. It can create a mess. It can create a catastrophic environment in the organization. So what we do, we perform the combination of developers and operatives. So when you combine these two operations and you add up some automations where everything works like a Azure like a agile infrastructure, where everything is flexible, you can approach to the tester can approach you with the issues, you can approach to the cloud computing executive. When everything works together in a flexible hybrid mode, that becomes a DevOps environment. Now, if you talk of DevOps, the most important software that you can see is Git, the puppet. Okay, like suppose if today I want to share my code, you want to improve some of the code, we can go to Git. Now today, let me tell you, even I'm a RHC certified, we have done Ansible. You know, even today, if you give me your company that, sir, we want 100 machines to be configured with Linux with this configuration. So what I have to do, I just have to write a code in Ansible and I just use SSL protocol in order to send that code via SSL layer to the machines and everything will be configured in brisk of a second. Today, let me tell you, madam, I have even made some codings in which I don't have to go practically to the server room. Even I have my codings, I just throw and update my codings to the server. So which means as an operative, I'm working with developers in order to accommodate and customize. So future industries today, starting from 2022, which they're having hypercity for cloud computing, the developers, the testers, the automation, it will be combined together under single roof with DevOps. This is the answer.
Thank you so much, sir. Thank you, sir.
Sir, Mr. Barney Dharan has asked in the chat box that whether SDN.
I'm taking up all the questions now one by one. Okay. So I will go for after that. Some people have given me some appreciation. Thank you so much. Okay. So can you explain the difference between cloud computing and SDN? Cloud computing is basically an environment in which everything is belonging to the third parties. Okay. Where everything has a cluster for your softwares, your hardware, your networks. It is done like that. But SDN is basically it is basically known as an entire ecosystem that can be sitting with your traditional networks and it can provide you to tune up your network in order to provide some advanced services. It is not like cloud, but even cloud can be part of SDN. Okay, so SDN is a big ecosystem. Okay, no, I cannot share the PPT. I'm sorry. Okay, so what is the key point of difference between SDN and other networks? So I have already told you that other networks like traditional networks are there where you cannot. Please mute yourself. Thank you. Madam, I will end the session now.
Sorry, sir. Sorry, sir. By the time you are trying to find out the source.
Please control. If these people are talking, you can see that they are not having any you can say attention towards me. Please remove them. I'm getting disturbed. I'm sorry. So SDN is basically other networks like traditional networks where you can't touch them, you can't update them, you need to add more operations and other things to testing. But SDN provides more hyperscale tuning. You can add up programming, network operating system, and even you provide some middlewares, and everything can be done. So, dear sir,
may I ask one question, sir?
Sir, excuse me, I will take your question, but first of all, let me complete the questions from the chat box. I will not wind up the session unless you're all stop answering your giving me the questions. Just wait for some moment. Please mute yourself. Thank you. Otherwise, I will stop the session now. This is the final thing from my side now. Dear sir, does SDN is more suitable for on-premise, and what are the challenges in SDN? So the challenges in SDN is only one thing that you all know that even if today we go for the interviews of Python developers or machine learning developers, 10 out of 1% gets selected. So how many of you know the coding of OpenFlow? So that is a challenge that we have very less people that are over there. And second thing is to convince the biggest telecommunication partners that, okay, we will not touch your infrastructure. We will add something they always fear. How can I give you my $1 million infrastructure, and how can I trust you that Open SDN will open new ventures for me? So this could be a challenge. But yes, Open SDN, like SDN based services, is also flexible. You can go for a test based environment. You can test it there. And then if it is okay, you can mix up with the DevOps, make the agile environment, and start going module by module. Okay. So that is the only answer. Okay. So I'm giving one more question, whether SDN is important topic for future researchers. Of course, I have already told you, because when you talk of 6G, when you talk of migration from today's, and now the most important challenge that we are facing, even today, most of the companies are calling me that, sir, today we have tons of data. Now we want to shift it to data center, to cloud. So what we do now, let me give you one answer. Most of the people don't know about it. I am a Amazon certified architect also. So there is a service in Amazon that is called Snowball. So you just call to Amazon and just tell them that, okay, we have a 80 terabyte or 10 petabytes of data. They will send you a Snowball, and you just migrate your data on the Snowball and send it to Amazon. They will add it to your cloud, and after that you can make your data anywhere and everywhere. It's like a multi-cloud tenant services. Most of the people don't know about it. So SDN is important for the researchers, because why? Because SDN is the only key when everything becomes under your control. Migratable control, when everything becomes under flexible, and of course you can tune your parameters as per the client requirements. That is why it is very important. Okay, so can you explain OpenFlow? OpenFlow I cannot explain, because it's like a protocol which is providing you with data pane and control pane services. You just have to install like into northbound API or southbound API, and after that you can code with Python, and of course it provides you with distributed services. It provides you traffic engineering, and it can hyperscale your traditional networks to modern networks. Okay, any other question? Okay. Sir, can we implement SDN for underwater communications? No. Right now, it is the most important challenge that we need to do. But let me tell you, I'm doing one project with Asian. It is about $80,000. And we are doing our server-based, cluster-based programming for underwater for underground sensor communications, but not for underwater. But underwater communications, I will assure you that in the next 2 years, I will be successful in that. But it is on my agenda, but not now, because my research is mostly towards drones, then towards IoT, cluster computing, and of course towards cybersecurity. That's the only answer. Apart from open source controllers like Onyx and Open Daylight, of course, like Mininet, if you have a real-time test bed, what are the solutions available? Of course, there are solutions, but the only thing is you need to program and you need to tune up your topology to make it inside applicable. But the only important problem is that you can't import the as such topology inside the Mininets. That is the reason, if you are really interested for simulation, I would like to request you can go for OpNet, or you can even go for OmNet++, or even today, there is a simulator known as NetSim. And if you add a toolbox of SDN, then it is working. But otherwise, it is too expensive. Okay. So I can say, is there any security issues? No, till date, I have not seen any security issues of SDN, because it is limited information. But till date, we have not seen any security problems or backdoors in the protocol. Till date, it is not. Okay, so what about SDN implementation when we have huge data to be manipulated? I have already told you that you just don't have to touch the traditional networks. You just add your SDN to the traditional data centers, and after that you can add up the Amazon services, or even today, if you talk of your the top services of the cloud like Amazon, Azure, they are even providing you with SDN services. So everything is available. Dear sir, I have heard everything about compute, storage, networks, and conversion, hyper-converged infrastructure, and here are the resources wasted since coupling. Please, what to do? The most important thing is to avoid coupling, is to find out that where the things or the resources are not working out. The only thing is you need to do some manual test bed, you need to do some benchmarking, and you have to find out that where are the problems coming up, especially not in storage, but in the networks. Because as a network engineer, even I'm a CCI certified, we have seen the problems in the network applicability, but computation, storage, and your compute things, they are perfectly working. So try to divert your attention toward networks. Sir, can you shed some light on interoperability aspects of SDN, which I've already explained to you, that if you're talking of interoperability, the only thing is that you need to add some controllers, you need to add some open flow, and then it will be going for interoperability. And of course, big data and cloud computing are of course in that. How DDoS attacks occurring in SDN networks if you're telling no security issues? I'm telling you that that DDoS attack is not a security issue if you add many people at the same time. DDoS today, if you talk of as the international NIST reports now, DDoS is not considered as a cyber security attack. DDoS is an issue which you have to find out the solution. If many traffics come to you, even today, if you're running up an institutional website, it can become under the target of DDoS. Okay, so DDoS should not be considered as an attack of 2022. So please check the Cisco. So how WSN can be added research part. So today, I'm sorry, I'm not taking up WSN, but yes, if you have a WSN question, you can give me a Madam, please remove him. Remove him, please. So when we're talking of now I forget where I was. No problem. I just closed the question now. Okay. No, it's okay, ma'am. It's okay, no problem. So respected sir, can you suggest any certificate course in DevOps? So you can do some certificate course from Being Cert. I'm a Being Cert certified DevOps solutions developer, Being Cert certified DevOps master. But of course, IBM and even Microsoft has DevOps courses. You can go to their website, and even I'm doing some courses from IBM also, but they're expensive. But I'm a crazy guy of certifications. And if you see my profile, I'm having 125 certifications in my career right now in the age of 38. So even I'm preparing more certifications for Azure and even for DevOps in my near future, but we are focusing most on Microsoft. Okay, SDN and ZigBee. ZigBee is basically a communication standard. ZigBee is not compared for SDN. So do MATLAB support simulation of this type? I have not tested MATLAB, and let me tell you, ladies and gentlemen, I am not against of MATLAB, but today, let me tell you very important aspect. Now, let me tell you, and this is an eye-opening session for all of you. Today, if you want to go to visit some internet, now this I'm not against of MATLAB, but make it sure that you should take my words very seriously today and right now. Now, let me tell you, suppose even I'm having my lab, I even open postdoc and even PhD positions. When you open for postdoc position, like suppose Miss Usha wants to do some IoT based postdoc under me. So I will check her profile on the basically known as specialized journals like computer networks, ad hoc networks, IoT journal. Okay. So in those type of standardized journals of networkings, they try to avoid the simulation based paper of MATLAB. They try to avoid. So they take only network simulators like NS2, NS3, OpNet, OmNet++, NetSim, QualNet. So do your focus only on that, because MATLAB based simulations, they can stuck your paper in the near future. But today, even I'm the associate editor of wireless networks. I'm sharing you very openly. When today the editor-in-chief allocates me the paper of MATLAB, my red arms come over the paper. Because why? Because MATLAB simulations are basically, you can say, diverted or even directed with lots of, you can say, assumptions, and we cannot assure the novelty of the paper. That's the reason we avoid that. Okay. So, okay, next question. So what is the low rate DDoS attack in SDN, sir? I cannot, because I'm not working for SDN based security. I'm working for SDN implementation, which is the main task. And when we have implemented our SDN for drones, we have not faced any sort of DDoS attack today. But yes, if you're talking of the major attack that still it is prevented, that is ransomware. But the complaints have not come, but still we are alert, because I have already told you, because as a hacker and as a cybersecurity researcher, even I'm a certified ethical hacker from EC Council, I'm a penetration tester, I'm a forensic expert. Today, many companies even ask me the question, sir, you are such an expert in cybersecurity, you can hack anything, you are a professional fisher. So do you provide us any solution for ransomware? I said, if the ransomware attack comes to you, pay the money to the hacker, because this is a problem. But complaints have still not come. But yes, if in the future it comes, the only answer is that yes, we have to add some AI based network controller with SDN infrastructure and architecture that can understand the behavior of ransomware traffic, and then we can curve that in that. Okay, so that's the answer I would like to take today. So now the person who was muting, please unmute yourself, and now you can interact with me. Hello, sir, are you there?
Yes, sir. Thank you, sir. Sir, actually, what is the maximum number of flow entries that can be handled by a SDN?
Maximum number of flow entries, what do you want to say? What do you want to say, sir? I don't understand.
Sir, what is the maximum number that can be handled by an SDN, normal legacy networks?
Sir, that matches the type of application. That matches the type of application, sir. Hello? Hello?
I think he's been disconnected, sir.
Maybe that's why his I was not able to hear voice and question properly. Anyways, no problem. But maybe if he connects again, then we can do that. Okay. Any other question? Maybe we can have some chat questions over there. We have no chat questions.
Shamiha, ma'am.
So what do you mean by decoupling in SDN? You can see that decoupling of the control planes and data planes, they become synonymous with SDN. So that's how we can say that decoupling happens. So basically it is to provide some mutual benefits with regard to the networks when the SDN data planes and the control planes are coming together. And that's how we can facilitate the network. Yes, I can take one more question. And after that, I will give you my contacts and everything. And you can contact me anytime for that. Okay. Okay. So I think all the questions are done. So let me give you some contact of mine. So this is my personal email, everybody. And this is my official email address. So if you're on LinkedIn, you can contact me here. My all the achievements and all the things whenever it happens in my career, my all papers are always when all the things are released on LinkedIn. So you can go to Google Scholar and you can search me. And if you're on YouTube, you can even see my channel, Gyan with Anand Nayyar. And when you talk of your WhatsApp, so only I'm available on WhatsApp. This is my Indian number, but please don't call this. I'm available on WhatsApp chat only. So this is my WhatsApp number. And you can do some Google search for me. If you go to Google, if like I can show you right now, let me show you. Just wait. So if you go to Google, everybody, and you just search my name. You can see that even my name is a search over there. So you can search and you can find all my information here with regard to my biography, my website, my links, my books, and everything is available to all of you. So if you go to my Google Scholar, you can see my publications, and even I'm hitting 7,000 citations today with 175 SCA publications. Okay. And you can follow me on ResearchGate also. So this is how you can be in contact with me anytime, anywhere. The email is welcome. And if you are interested to do the postdoc with me, you are most welcome to send me these documents, which I'm going to tell you, because very soon I'm going to hire 3 postdocs. One postdoc will be working in the area for IoT. The second postdoc will be working in cybersecurity. And the third postdoc will be working with me in terms of multimedia services, where we can provide with regard to digital twin and of course with AI in healthcare. So what you have to send me is a teaching statement. And after that, you need to send me your research statement. And of course, after that, I need your resume, your list of publications. And the requirements are very simple for postdoc. Please, thank you so much. Please just don't type any message on the chat box, because I'm communicating now. Please don't type anything. So for the requirement of the postdoc, the only requirement said that at least if you are a PhD, you need to have the PhD plus at least 2 years of experience, PhD with 2 years of experience, post PhD minimum. And after that, you need to have 10 to 15 SCI papers. And in that 10 to 15 SCI papers, we require no special issues, no open access papers. And all the papers should be in, you can say that is called your directive journals. Like suppose if you're adding up into cloud computing, so your paper should be like in computer communications, networks, IEEE transactions for cloud computing. So we are looking for only directive papers in directive journals, and additional support will be 2 to 3 conference papers in A-star conferences. So these are the requirements for the postdoc to work with me, and the person should be ready, because in Vietnam, let me tell you, whole of the world is with the 4 days or 5 days based scenario. In Vietnam, there is no 4 days or 5 days. There is no holiday. We are working 24/7. Even on Sunday, we are working. There is no Saturday. There is no Sunday. We are totally flexible people for the labs, because my lab is already on $2 million, which we are taking up projects, and we are adding up more and more projects with the industry. Even if we are having collaborations with Korea, we are doing some projects with Hyundai, Samsung, everywhere we are doing the projects. So you must be flexible. You must be hyper available with all of us. There is no means for anything. Okay. There's no shortcuts. So thank you so much, everybody. And please be in touch. I have given you everything, and you are most welcome to email me or give me a WhatsApp message whenever you want. But I'm a busy man, so I prefer to have some email communication always, because my email is replied within 15 minutes to maximum 90 minutes, whatever the email, because I receive more than 2,000 emails a day, but I reply to each and every email on that same day. That is my duty that I do as a scientist in computer science. So thank you so much. Thank you, Usha ma'am, for calling me. It's a real wonderful session, but sometimes you can understand that some people disturb in between the noising atmosphere, so which should be avoided for the next time. But that is the only thing that I don't like in between, but otherwise everything went very smooth. Thank you so much for that.
Thank you so much.
Thank you, sir. Thank you for addressing all the queries very patiently, and thank you for sharing your contact as well. Thank you so much, sir. Participants, the feedback link is in the chat box, and for the YouTube participants, the feedback link has been posted in the live chat. Kindly fill it. E-certificate will be provided only after attending all the 5 days of the FTP. Thank you. To place our gratitude, I call upon Dr. Sharada, Assistant Professor, Miyasi Institute of Information Technology.
A very good evening to one and all gathered here. It's my privilege to propose a vote of thanks today. First and foremost, I would like to thank the Almighty for blessing us with a great day. On behalf of MIIT, I express my sincere thanks to the management for their encouragement towards all our initiatives. I express my sincere thanks to our Secretary, Janab Elias Syed sir, for giving this wonderful opportunity. Also, I express my gratitude to Mr. Yusuf Muhammad Sahib, convener of MIIT, and all other executive committee members of MIIT for their constant support. I would like to extend my gratitude to our resource person of today, Dr. Anand Nayyar, for his valuable time and for giving a lot of insights on software-defined networking. Thank you, sir. A special thanks to our respected director, Dr. Revati ma'am, and head of the department, Dr. Usha ma'am, for the immense support in conducting a successful session in 5-day FDP program. I also thank all the professors for their presence and support. Last but not least, I thank all the participants from various colleges across India for their presence and active involvement. I also thank the YouTube audience for their engagement. Once again, thank you each and everyone for your presence and for making the first day of 5-day FDP successful. Thank you.
Thank you so much for readily accepting my invitation, sir.
Always welcome, ma'am, and I look forward for more collaboration with you.
Definitely, sir. Thank you.
And in the future, we can have some more lectures with regard to metaverse and we can have some AI in healthcare, Internet of Medical Things, digital twins, and even we can have some more seminar for the faculty members with regard to research methodology, which is my specialization. That is how to write a paper, how to get the paper accepted, and how to avoid the rejections in transactions and high-end journals that we can cover in the near future.
Definitely. Thank you so much, sir.
We will arrange soon, sir. Thank you so much, sir.
Thank you. Thank you, everybody. God bless.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.